Welcome back everyone. Thanks for joining us again. I hope the earlier content was helpful. So let's move on to the next section of QMS, that is equipment management in the blood banks. Now let's look at some key strategies for effective equipment management. First, we start with a needs assessment. This helps us to determine what equipment is actually required based on our operations and goals. Next, we define the functional and operational specifications, basically what the equipment must do and under what conditions. Then comes design qualification, or called as DQ, where we ensure the equipment design meets all the required specifications. After that, we focus on appropriate selection and procurement. This includes vendor evaluation and checking equipment suitability. With the equipment in place, we conduct an installation qualification, verifying the equipment is installed correctly. Then we do an operational qualification. This confirms the equipment functions as intended under normal conditions. Following that, we perform a performance qualification to check if the equipment consistently performs under real conditions. We also implement regular maintenance to keep the equipment in top condition. Repairs are handled as needed to fix any issues promptly. We aim for optimum utilization, making the best use of the equipment without overburdening it. And finally, we ensure timely replacement, retiring the equipment before it becomes a risk or an inefficiency. So together, these strategies ensure equipment is reliable, safe, and effective throughout its life cycle. First is equipment selection. It should be based on design qualification and need assessment. Like, how do we assess whether it is needed or not? So that is by determining the use coefficient using the formula N by M into 100, where N is number of hours the equipment is used per day by the maximum number of hours the equipment can be used per day. So I use coefficient of less than 50% warrants that equipment should not be economically viable. For example, the centrifuge is in operation for 5 hours a day and the maximum recommended usage is 8 hours per day. So 5 by 8 into 100 is 62.5, which is greater than 50. That means it is needed. Let's now talk about what needs to be ensured before installing any equipment. The first and foremost, all physical requirements must be met. This includes power supply, proper electrical connections, adequate space, accessible doors, ventilation, and water supply if needed. And the blood bank must clearly confirm the vendor's responsibilities for installation, and this should be done in writing before the installation begins. It's also important to prepare a checklist of expected performance specification so that we can verify if the equipment is functioning correctly immediately after the installation. And this installation should be handled only by the manufacturer to ensure it meets all the technical and safety standards. And finally, the equipment must not be used until three things are complete. That is, the installation is finished, performance has been verified, and all the relevant personnel are properly trained or not. So these steps help ensure safety, compliance, and effective operation from the start. Now there are three main protocols used for equipment qualification. These are essential steps to ensure equipment is reliable, safe, and functioning as intended. First is installation qualification, or IQ. This ensures that equipment along with all its components and documentation is installed correctly, strictly following the following the manufacturer specifications. Next, we have operational qualification. In this step, all major parts of the equipment are tested to confirm they operate correctly and importantly that they work in synchronization with the entire system. Finally, there's a performance qualification, or PQ. Here the equipment is monitored over a period of time to make sure it consistently delivers accurate results within the required performance parameters. So together, IQ, OQ, PQ from the backbone of equipment validation, ensuring everything works perfectly from setup to long-term use. Now we'll get into more detail about installation qualification. So this process is typically performed by the manufacturer's field representative. The person who is trained and authorized to set up the equipment properly is a manufacturer field representative. So during IQ, several key checks must be made to verify that everything is in place and ready to function as expected. So all the component parts must be present and they should be functional. The local supply voltage must watch the equipment's requirement, The ambient temperatures like temperature, humidity, ventilation should be suitable for the equipment to perform optimally, and the correct version of the software must be installed. In addition, the manufacturer's representative should set up all the basic instrument parameters such as date, time, language, and any required test protocols. Finally, the calibration should be done at this stage. This includes calibration of major equipment, accessory tools, and even utilities to ensure everything is operating within the required specifications. So this ensures the equipment is not just installed but installed correctly and ready for reliable use. Next, we move on to the second step in equipment qualification, that is operational qualification or OQ. So at this stage, all the major parts of the equipment are tested to ensure they operate correctly and work in synchronization with the entire system. So operational qualification is typically carried out jointly by the manufacturer's field representative and the laboratory technician as well. So this collaboration ensures that the both technical and user perspectives are covered. So this step should include a full verification of the operation of all the system components. That means every element, part, service, control, and any other relevant components must be checked. And importantly, all of this testing must be documented. The results go into an operational qualification report which serves as proof that the system functions correctly under expected operating conditions. So this step is vital because it confirms not just the equipment is installed but that it actually performs as intended when in use. The final stage of equipment qualification is performance qualification or PQ. This PQ is all about evaluating how well the equipment performs in real working conditions. Specifically, we check for accuracy and precision, making sure the equipment delivers consistent and reliable results over time. So this step is performed jointly by the manufacturer's field representative and the technicians in the lab, ensuring both technical setup and practical use are assessed. By completing PQ, we confirm that the equipment doesn't just function, but that it performs correctly and consistently during routine operations. Once the installation qualification, operational qualification, and performance qualification have all been successfully completed, an installation certificate should be signed. So this serves as official confirmation that the equipment has been properly validated. However, this equipment is not yet ready for use until one final step is taken. The in charge of the blood bank must give formal authorization to use the equipment, and this should only happen after all the validation criteria have been fully met. So this ensures a controlled, safe, and compliant start to equipment operation. Now we'll talk about the maintenance plan because it is a crucial part of keeping the equipment in good working condition. So a well-structured maintenance plan should include several key components like routine cleaning and sanitation to prevent contamination and ensure hygiene, provision for inventory, making sure necessary tools, spare parts are always available, and troubleshooting procedures for quickly identifying and addressing the issue, and adjustment to fine-tune equipment as needed for accuracy, then repairs to fix any faults that occur during use, and a scheduled replacement of equipment parts to avoid unexpected breakdowns. So these maintenance tasks should be performed at fixed intervals, whether that's daily, weekly, monthly, or yearly, depending upon the equipment and its usage. So regular maintenance not only extends the life of the equipment but also ensures consistent performance and safety. For example, for refrigerator monitoring, the temperature chart should be recorded 3 times a day. So this helps ensure consistent monitoring. Use a digital thermometer and make sure the temperature stays within the ideal range of 2 to 6 degrees Celsius. And the chart operates on a clockwise mechanism which should be checked regularly to ensure it's functioning correctly. And don't forget, the chart should be replaced weekly to maintain accurate records. Inside the cabinet, use a precision thermometer to measure the actual storage conditions. And the alarm system must also be checked. This is done by immersing a sensor in both low and high temperature environment, and this test should be done once a week. And of course, the unit must be kept clean at all the times to ensure hygiene and proper function. For deep freezers, if there is no automatic defrosting system, it should be manually defrosted as needed whenever there is visible ice buildup or impaired performance. So these steps are vital for maintaining the integrity of stored materials, especially in sensitive environments like blood banks. For refrigerated centrifuge maintenance, the centrifuge should be checked by a service engineer every 3 to 4 months to ensure it's operating properly. For accuracy, the speed and time settings should be verified using a precision tachymeter, and the temperature inside the centrifuge bowl should also be checked regularly with the temperature tester to ensure it stays within the required range or not. For benchtop centrifuges, the same checks should be carried out for every 3 to 4 months, and regular maintenance is essential to ensure the centrifuge functions effectively, especially for sensitive applications. Moving on, we'll discuss about the importance of calibration and how it ensures the accuracy of equipment. So the calibration should detect and correct any variations from the required performance specification of measurement devices. So this is crucial in blood bank setting, as calibration is required for all the measurement devices or equipment that provides critical information such as weight, absorbance, temperature, time, length, width, volume, RPM and pressure. So this ensures accurate calibration of these devices, helps maintain the reliability of results and the safety of operations within the blood bank. So this calibration schedule and standards should always align with the national standards, ensuring consistency and compliance. So recalibration should be performed based on several factors including the type and use of equipment, its tendency to wear and drift over time affecting the accuracy, and the uncertainty of measurement, meaning how much the variability the equipment might have. So this calibration should also be done whenever the equipment is serviced or if its location changes, and as these factors can impact the performance. So these situations are referred to as trigger events, instances that require recalibration. And it's important to maintain calibration certificates, which should include the following details like date of calibration, name of the calibrator, correction factor applied, and due date for next calibration. If calibration is overdue, it should be carried out by an NABH accredited calibrating laboratory. This ensures traceability of the calibration method, guaranteeing that the measurements are accurate and reliable. When it comes to service contracts, the provision should be made with the manufacturer to ensure proper maintenance and servicing. This maintenance can either be performed by the manufacturer themselves or an external agent. It's important to establish a procedure for scheduling regular service, and this should be done periodically by the manufacturer to ensure equipment remains in the top condition. For major equipment repairs, always rely on the manufacturer to handle the repairs, ensuring they are done correctly. Finally, all the service activities should be documented, and the service engineer and the responsible person from the blood bank should sign off on the work performed. Let's now look at the difference between the two common types of service contracts, that is AMC and CMC, the annual maintenance contract and the comprehensive maintenance contract. So an AMC is an agreement where the company commits to provide maintenance and support services for a customer's equipment over a span of 1 year. It primarily covers reactive maintenance, that means repairs and services when something goes wrong. Typically, an AMC lasts for 1 year, and this may be sufficient if you only need basic support and occasional service. Whereas CMC, on the other hand, it includes not only a reactive maintenance but also proactive services such as training, system upgrades, and preventive maintenance. A CMC usually provides both proactive and reactive maintenance. It can extend for multiple years, and a CMC may be more suitable if you require comprehensive coverage and a long-term support. In short, if your needs are minimal and reactive, an AMC might be enough, but for long-term support with additional services, a CMC is likely a better option. When the equipment is removed from the direct control of the blood bank for repairs or servicing, the blood bank must ensure that the equipment is checked thoroughly and confirmed to be functioning properly before its return to service. So the equipment should be checked in two main ways. First, by calibration to ensure that it meets the required specifications. Second, through verification or testing to confirm that the equipment meets specified acceptance criteria for proper operation. So this ensures that all the equipment is fully functional and safe to use when it's reintroduced to the blood bank. And that covers the importance of effective equipment management. I hope you found this topic helpful and informative. So thanks for watching, and don't forget to like, share and subscribe for more updates. See you in the next video.